Yeah, let's do it. What we were doing triangles last time, weren't we? Yeah.
All right, I'm back.
Cool. Okay. Let's do a couple things right here. Okay. Ooh, actually, here's what I'm gonna do. Let's do a quick review. See if you remember things. Okay.
All right.
Always good to be like, does he remember it? This is the classic one they love to do. Someone saying something. One sec. Hot boy summer. Hot boy. Yeah, Michael. I was about to say like I feel a lot better today, Michael, than I did yesterday. So I'm like, hot boy summer just needs to be delayed by a week because now I have to quarantine for a week. Yeah. And Patty says he's negative too. So. Just annoying. I think I'm addicted to hot boy summer. Yeah, hopefully your bank account isn't addicted to hot boy summer, Michael, dude. That'll get you, bro. Hot boy summer isn't cheap. Oh man. Okay, cool. Let's see. And like, let me give you one of these. Let's make this one. Okay. Can you see the screen there, T-Bone?
Yeah.
Okay. First thing, so the question is going to be find and label all of the angles. That's what they say. Angles.
All right.
Cool. So let's try and do this. So anything that has like one of those little half circle things, that's an angle.
All right.
All right, T-Bone, let me know when you got it.
All right. I think I might have it.
All
I'm
right.
not sure though.
Let's see what you got. Let me know what you got.
All right. So for angle ACB,
ACB, good.
I got 110.
Ooh, not quite.
No.
So which angle do you think is ACB? Which one do you think is ACB?
The one to the left of C.
This one right here?
Yeah.
So you labeled it correctly. That's ACB. Good. Remember ACB? It's like that.
Yeah.
Okay. Why did you say it was 110?
Because I think I subtracted 30 from 140.
30 from 140. Interesting. So not quite. So vibes, you had this, right? Acute and obtuse. Yeah. Okay. So let's remember, if you have a straight line, right?
Yeah.
And you divide it with another line like this, right?
Mm-hmm.
What's the sum of these two angles?
Oh, it's 180.
Good, good. It's 180. Yeah. A, a,
Okay,
a
okay.
straight line, right, is always 180 degrees.
Yeah.
Good.
So 40.
Right. And vibes. An acute angle is an angle that's less than 90 degrees. An obtuse angle is one that is greater than 90 degrees.
Wait. So would it be 180 minus 140?
Good.
All right. So then ACB should be 40 degrees, I think.
Good. Good, good. Very good.
And then those two combined make 70. 70 minus 180. Would the top one be 110?
Top one. Yes, it would be 110.
Oh, well,
What's
ABC.
ABC? Good, 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 good. Nice, dude. Nice. Where's my soundboard? Come on, soundboard. There you go. Very good, very good. Yeah, 110 degrees. There you go. We get some delayed gratification clapping, dude. Yeah, very good, very good. Yeah. So the key things that T-Bone used here, guys, is that two angles, if they make up a straight line, got to add up to 180. So that's how we got this one to be 40 degrees. And then within a triangle, you need the sum of all the angles to also add up to 180 degrees. Because the sum of the interior angles of a triangle is 180 degrees. Very good, very good. Okay, cool, cool, cool. Okay. Let's go over another thing here. Do you know what parallel lines are, T-Bone?
Is it like lines that are the same length?
Not exactly same length. That would be congruent lines.
Like
What
this.
what does it mean to go parallel to something?
Like to do the same thing it does?
Same thing it does, but like slightly different, right? You know.
Yeah.
Here's an example of like parallel lines. Next to. Yeah, parallel. Yeah, parallel does kind of mean next to, Bond. You're right. You're right. So do you see these are called did some parallel lines last weekend. God damn it. uh, he's talking about parallel line dancing with the girls, of course, right? Sniff, sniff. Good. Yeah, lines that don't intersect. Very good vibes. Yes, yes, very good. Yeah, so parallel lines are lines that will never intersect with one another. Okay,
Yeah.
These are called parallel. And the way they'll indicate that two lines are parallel to each other is they'll do this. They'll put like a line through them, like two lines through them. They'll be like, this is parallel to this or something. Is what they'll say. Because if for instance, let's say they were like this, right? Let's say there was a line like this and a line slightly like this, right? Do you see how this one eventually would have intersected with this one? Right here?
Yeah.
Yeah. So these are not parallel lines, is what they are. These are not parallel. Okay, cool. And then the last thing we need to know are perpendicular angles. What do you think perpendicular angles are?
The lines that cross?
They do cross. Very good. They do cross, but there's a special way that they cross, right? What do you see as special about the way these two lines cross each other?
They're like both straight.
Both straight. Yeah, good. So what's the angle between these two lines?
180?
Not quite. Not quite. That's the angle between a straight line. A straight line is 180 degrees, right? What's this angle right here?
Oh, 90?
90.
Nice.
Good. Yes, 90 degrees. 90 degrees, right? Yeah, good. Good vibes. 90 degrees. Yep. That's what perpendicular angles, perpendicular lines are. Perpendicular lines are lines that when they intersect, they intersect with a 90-degree angle. So another word for this is things that are orthogonal, is what they'll say. It's another word for it. Okay, cool. Yeah. All right. So there's a cool property about parallel lines. Okay, let's say we have two lines. Or here, let's make them straight. Actually, let's make our life easy. Yeah. B, C, D. Okay. So a lot of times they'll say, like, for instance, they'll say that AB is parallel to CD. Okay.
Okay.
Remember, like, this is how you label a line, right? You say the 2 points. 2 points to find a line, right?
Yeah.
You need 2 points to make a line. And this tells you that it's a line because it goes all the way to the left and right. If this was just a segment, like if we got rid of this, for instance, you'd also get rid of this.
Gotcha.
And a lot of times, actually, this is what's said. They don't do lines. They do line segments. So let's do this. Yeah. Okay. Okay. You have two parallel lines, and let's say, for instance, another line intersects both of these. Okay. So let's say we have another line that just comes through like this. Okay.
All right.
So you see how this creates a bunch of different angles, right? You see how we have
Yeah.
this angle, right? So let's call this a different point. Like a straw. Yeah, a straw is definitely a thing used for parallel lines, Michael. Okay, good. Let's call this like E. Let's call this like F. Okay. Oh, then usually you gotta put labels on this as well. Let's call this like G, and let's call this H. Okay. Okay. Do you see how that putting a line between two parallel lines creates a bunch of different series of angles?
Yeah.
So it turns out if two lines are parallel, there's a thing called corresponding angles. See how this is? Do you see how this angle here looks kind of the same as this?
Yeah.
These angles. So first of all, how would I label this angle right here? How would I label this one?
HFD.
No, HFD would be this one, right? HFD. I want to do this
For
one.
the grid. Oh, for the grid thing.
Yeah.
EFD.
Good. So here we got corresponding angles. So angle EFD is also going to be equal to how would I label this angle up here, T-Bone?
GEB.
GEB. Very good. Nice. Yeah, so those are called corresponding angles. Okay, so let's think of another one. Okay. What about, okay, here's another cool fact that also works, is what we have between this angle and this angle. How would I label this angle? This one right up here.
AEF.
AEF, good. Right, yeah. So it turns out that these two angles, as a pair, form what we call alternate interior angles, okay? They're called alternate because see how this one's on this side of the red line and this one's on this side of the red line?
Yeah.
And they're called interior because they're on the inside of the parallel lines. Okay? So this would be alternate interior angles. And these are also equal to each other. So angle EFD is also equal to angle AEF. Right. So, and actually, there are a couple. We'll go back to the. Okay, so if we have alternate interior angles, what do you think could be another series of angles? If we have alternate interior, what's another type? Alternate.
Would it be CFH and
CFH.
AEF?
Oh, C. this one, and AEF. Oh, these ones. Okay. So interesting enough. Yeah. These are also a pair. These are also called corresponding angles. Because do you see, like, in the whole quad here, this is the bottom left. And in the whole quad here,
Yeah.
this is also the bottom left.
Yeah.
Good. Those are also what we call corresponding angles. So this would be like angle. You're right. CFH, right? Or you said HFC, I think is what you said. Doesn't matter what order. As long as the F is in the middle. HFC and AEF, yeah, those are also corresponding angles. And then say, for instance, so what would the corresponding angle to this one be? HFD.
FEB.
Yeah, good.
Nice.
Yes, that's another corresponding angle. So you have also HFD is also equal to FEB. Okay. Now, if we have, so there are more corresponding angles, right? Like this one was this one. You already did that one. But also this, right, corresponds to this one. This one corresponds to this one. This one corresponds to this one. So yeah, let's just put the fourth one just to be complete. So we also have angle EFC equal to angle GEA. Okay. All right. If we have alternate interior angles, what's an opposite thing to an interior?
Would it be DFH and CFH?
So you're saying this one and this one. Okay. Those are supplementary angles, right? Because those add up to 180. But okay, what's not even thinking about like letters or whatever. What word is opposite to interior? If something's not in the interior, it's in the what?
On the outside.
Outside. What's another word for outside? It starts with an E.
Exterior.
Nice, dude. Yes. So now we have another set of angles you need to know, which are called alternate exterior angles. Yes, good vibes, dude. Yeah, nice. Exterior angles. Okay. So, do you remember how like this one and this one were alternate interior angles, right? Because again, they're on different sides of the red line, but they're still in the interior. So if I have alternate exterior angles, where do you think the exterior angles are?
Would it be the bottom?
Good. It's going to be these angles with these angles. So what's an example of some exterior angles?
HFD and AEG.
Good. Nice, dude. Yes, perfect. So HFD is equal also to AEG. Good. Very, very good. Yes, these are the things you need to know. So, right. See how this angle is on the alternate and it's exterior? Good. And also, right, these two would form a pair, right? Because these are also alternate, but they're on the exterior. Yeah, okay, cool. Nice. Okay, so knowing that, you can actually do... So this is a very cool property of parallel lines. And you can use this to figure out puzzles with angles. So let's see. Let's figure one out real quick. Yeah, they love these. They love these. Let me think. Do I want to do this one? Yes, this is a good one. Can I just put this image, please? Put it in place. Come on. No. Yes. Okay, here's a good one here. All right, T-Bone. They want you to figure out what angle Z, angle X, and angle Y are. Okay?
EX. Alright.
And what they tell you, like what you're given will be, is that line AB is parallel to line CD. I want you to figure out. Give me angle X, angle Y, and angle Z.
Alright.
So which one are you going to try and figure out first?
Probably Y.
Cool. Okay. How do you think you can figure out angle Y?
Would you do 180 minus 33?
Not quite. Because 180. Well, so let's look at this real quick, right? 180 minus 33. What would that equal? Like
Let me see.
147.
Yeah.
Does this angle look like it's 147 degrees?
No.
What would 147 degrees look like?
Like wide.
It'd be really fucking fat, dude. It'd be like this, right? So, yeah. So it can't be 180 minus 33, right? Because you know this angle and this angle aren't like sharing like a point and a straight line, right? You'd be correct to like, all right. So if I kept drawing a line, for instance, this way. Let's say I just kept doing it. Let's say I kept drawing the line this way. You'd be right that 180 minus this angle would equal this angle, right? Because this angle and this angle both share a line.
Yeah.
But no, so not quite. I'll give you a hint. We have to use something that we literally just learned on the last page to figure this one out. And it has to do with there being two lines that are parallel. Okay? Sometimes it can help, T-Bone, like if you see lines and whatnot, to just make the lines longer. So let's make the lines longer. Let's do this, for instance. Well, one sec. Maybe this will help you.
Would you do 180 minus? Oh wait.
Yeah, see, you can't do any 180 minuses because you don't know any of the other angles. I'll give you a hint. It's one of the things we learned. It's one of these things we learned. One of these things we learned. See how this is two parallel lines?
Oh.
See how two parallel lines, and we have a line cutting it in between. We got two parallel lines. I just made the lines a little longer. You can always just make the lines a little longer. Sometimes this helps people out.
Are those two angles the same? Like
Which
in
ones?
the middle?
Yeah, which ones?
Like where the X is, the top and the bottom.
This one. And which one?
No,
This one?
No, like wait. I don't know how to. Like where the red line intersects the other line.
which line? Line
like
AB
like
or line CD? Or are you talking about this line ED? See, here's the cool thing. You can tell me what line it
middle
is.
Of that one.
Okay, you're saying where this intersects?
Yeah. Would that be like the middle of ED or CB?
That would be the middle of ED and CB, right? Yeah. But you're saying that this angle equals one of these other angles?
Like does the top equal the bottom one?
Oh, does this one equal this one? Yes, correct, yeah. Correct. They do. Okay. Yeah, that's true. Yeah, this one does equal this one. But you don't know either of those, so that doesn't really help you. There's something special about, for instance, this angle and this angle. So, are these two angles on the interior or on the exterior?
Interior.
Good. What about, are they alternate? Are they, what are they?
Yeah. Wait.
So let's go back to the other page here.
Is it alternate interior?
Good. Yes. Yes. Good. 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 Yeah. Good. Good. Yes. Yeah. 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 These angles are alternate interior angles, right? See how? Again, they're on the interior of two parallel lines, and they're on the they're on the opposite sides. So these are called alternate interior angles, or opposite interior angles, I think is what they call them, maybe. Is that another word for it?
Are those two the same size?
Yes. Yes, good. They are. They are the same size. Let me see. What do they call? Do they call these alternate interior? Yeah, alternate. Okay, they do call them alternate. Yeah. Okay. Good.
So, would y equal 21 then?
Yes. So you would say that angle y is also equal to 21 degrees because of alternate interior angles. Okay? So again, anytime you see two lines that are parallel, think about what's connecting them, and you can kind of make a bigger line to kind of see like where is the alternate interior, alternate exterior. Okay, good. So you know this one is also 21 degrees. Okay.
So would z be 33?
Yes. Because you see how these are also alternate
Interior
angles?
Yeah.
Good. So angle Z is equal to 33 degrees. Okay. Now what about angle X?
Let's see. Well, since it's on that line, couldn't you use the wait?
Yeah. You can use the. I know what you want to say. You can use it.
Like you could use z like 33 for the like for 180 and whatnot.
Yes.
Nice.
Yes. Because see how these are both on the same line, right? So this
Yeah.
one and this one have to add up to 180. So yes. So that's. I think there's a name for that. I think that's called collinear angles. I think they're called collinear angles. Yeah. Okay.
Gotcha.
Okay. Angle Z
So
is
then-
equal to angle X. Or sorry, angle Z plus angle X is 180, right?
Yeah.
So what does angle X equal?
147.
Good. Yeah, very good, dude. Yeah. These are called collinear angles. Okay.
So using like the other angles help you find the other ones.
Uh-huh. Yeah. That's what a lot of geometry is using one angle to find another angle.
Gotcha.
Yeah. So yeah, you're right. So these are called collinear angles. What does co mean? Like in Latin, like a prefix or something. I don't know.
I don't know.
What if you're like codependent?
You rely on something else.
Good. You rely on each other is what it is.
Gotcha.
So, and linear, right? You see the word line in there, right?
Yeah.
So collinear means that things share the same line. You see how this angle and this angle share the same line, right? They share this line.
Yeah.
That's why they're called collinear angles. Yeah. Good, man. Nice. Let's see. We've got like probably time for one more. Ooh, they want to make a tough one here. Ooh, this is a toughie. This is a toughie one here, dude.
Oh boy.
Yeah, let's see this. Yeah.
Oh boy.
Right? So let's get these three angles. Or there's
Oh,
four
I
of them.
think I already know how to solve.
You do?
C.
Okay, good. Yeah. How do you solve for C?
Would you subtract 154 from 180?
Nice.
Yes, dude. Yeah. So angle C is just gonna equal 180 minus 154. Yeah, this is they do this all the time in geometry class, and this is why I kind of like geometry sometimes, because it's a puzzle. It's all just a fucking puzzle. Like, okay, cool. This one's 26 degrees. All right. What now?
Is angle like wait? Is USQ the same as TSQ?
So USQ would be this angle, right?
Yeah.
TSQ would be this angle. Yeah,
Wait. So
those can't be the same, obviously,
it
right?
goes through the line.
Uh, yeah, yeah, right, yeah. USQ, this whole one right here. Yeah, this line
Oh,
like
that's the
splits
whole.
it. That's the whole line.
Okay.
I'll give you a hint. It has to do with the parallel lines. So which lines are parallel?
Uh, T to S and then P to R.
Yeah, very good, very good. See how this line is parallel to this line? Yep.
Yeah.
Okay. Is that going to help us figure out another angle? What's a line that intersects these two parallel lines?
UR.
UR does. You're good. Yeah, UR actually does. Yeah. Okay, good.
And then QS does too.
Right. You see how this one intersects, and then this one also intersects.
Yeah.
Is that going to help you figure out an angle? Here, let's focus on one for now. Let's just focus on the UR intersecting. What is that going to help you figure out? What angle is that going to help you figure out?
Am I trying to get A, B, C, and D?
You already have C, but yes, you're trying to get this one,
Yeah.
and this one. I'll give you a hint.
Alright.
You want to use this line intersecting these two parallel lines to find angle B.
For B. I think I know what
Yeah.
A might. Would A be 48?
No, I see. You
No.
think it's splitting it. No, it's not 48.
Yeah. Let's see.
Yeah, here's another thing in geometry. You can't look at something and be like, oh, it looks like it splits it. It has to be like because of a certain law or a theory or a theorem or something.
Okay.
So what do we know if we have two parallel lines and we have a line that intersects it, right? We know there are a couple different things, right? We have corresponding angles, we have alternate interior angles, and we have alternate exterior angles, right?
Yeah.
And within those families, those angles all need to be the same, right?
Mm.
So angle B, for instance, down here, right? Which one is also kind of like angle B up here?
Oh, wait. So would it be SBQ and then UST? Or wait, what is it?
SBQ. Okay, so yeah, this one and this one, right?
Yeah.
Yes. Those are the same. And why are they the same? What type of angles are they? Because they're
They're
the same.
interior angles?
No. This one's exterior. This one's interior. Right? See?
Oh, so it's corresponding?
Good. Yes, corresponding. So look at this. Do you see how like this is, for instance, the top left angle, right? And on this one, again, it's the top left angle.
Yeah.
Good. So angle B is equal to 48 degrees. And so this one was because of collinear. This one is because of corresponding angles.
Gotcha.
Okay, cool. Okay, so now we got that this one is equal to 48 degrees. What else is that going to help us with?